When writing code, most of the time we'll be dealing with data. We're either storing data in a database or some storage, or we'll be sending data or serving data via HTTP. JSON is a common data structure used by microservices and distributed systems for sending data across the wire. In a previous video, we've learned about the fundamentals of the Go programming language, and in this video we're going to turn it up a notch by looking at more realistic data and how to deal with data structures, specifically JSON. So without further ado, let's go. So in part 1 of our series, we've taken a look at how to install the Go programming language and also how to run the Go language in a container. So if you take a look at my GitHub repo, I have a Golang folder, and in the Golang folder I have an introduction folder with a README, and this is my introduction to the Go programming language. If you're new to Go, check out the link down below to my introduction to Go so you can follow along. In this video we're going to be taking a look at part 2, which is specifically to deal with JSON, and in this folder we also have a README, which is the next part to the introduction to Go for dealing with JSON. So the first thing we're going to need is a development environment. So what I'm going to do is I'm going to change directory to the Golang introduction part2.json folder by saying cd Golang introduction part2.json. I'm going to copy that, paste it to the terminal, and change directory to that folder. And in this folder I have a Docker file, which you can see here, as well as the README that we're looking at. And if we take a look at the Docker file, it's a very simple file saying from Golang 1.15 running a small Alpine container, and it also specifies a working directory, a folder called /work, and this is where we'll be doing all our work inside of the container. We will mount all our source code from the file system into this folder so that we can work inside of the container. To build and run this container, it's very simple. I just say docker build, and I specify the dev target, and I specify dot because we're in the folder where the Docker file lives, and then I tag it as go. So I copy that, paste it to the terminal, and that'll build up our container image for our dev environment. And then to run it, I say docker run -it for an interactive terminal, and I say -v, and I mount in the working directory, and I mount it into a folder called /work. That's our working directory inside of the container. And then I also specify the image I want to run, which is go. That's the one we tagged earlier, and sh for a shell terminal. So if I run that, that'll go ahead and run that Go container we've just built. It'll also mount in this entire part2 folder into the container, and we're inside the container in that work folder. And because we've mounted a volume, I can say ls, and we can see we have our Docker file and our README. I can also say go version, and we can see I have access to the Go programming language version 1.15.6. So now I don't have to have Golang installed on my machine. I can simply build and access it inside of a container image. This is a completely optional step if you don't want to install Go on your machine. As per our introduction to the Go programming language, we always start out with a folder which represents our Go repository, and then we create a module to hold our application, and we start with a hello world base. So let's create our application. Now the first thing we always start with is creating our Go repository. So what I'm going to do is just create a folder that represents our repository called videos. So I say mkdir videos, and that'll create a folder on the left here for videos that'll hold our Go code. And we're going to create an application that deals with videos. So then I go ahead and change directory to that videos folder. And the next thing we need to do is define a Go module. So I say go mod init videos. And when I run that, that'll go ahead and create a new Go mod file, which you can see on the left hand side here in the videos folder. And if I click that file, we can see it defines our module called videos, and it's running Go 1.15. So now we have an empty Go repository, which is our videos folder, and we have an empty standard Go module file defined over here. So next up, let's create our first Go file, which is going to be our main entry point to our application. So what I'm going to do in the videos folder is I'm going to create a new file called main.go, and then I always like to start with a hello world application. So what I'm going to do is just copy the snippet of code, and I'm going to paste it into main.go. So in our fundamentals video, we learned how to define a package. So every Go file is part of a package. So we define package main, we import a standard library, which is the FMT package, and we have our main function, which is going to represent the entry point of our application. Go will run this whenever we execute our code. And the only thing we're going to do in here is say fmt.println hello world. So we're just printing a hello world message to the screen. To test this code, I can just say go build, and we can see it produces a binary on the left side here. And to run that binary, I just say /videos. And we see hello world prints to the screen. So our code is good to go. So in our Go fundamentals video, we've learned about how to define a Go repository, how to create a Go module, how to define a package for that module, and multiple Go files that form part of that package. We've also taken a look at the fundamentals such as variables, types, structs, and loops, and all the basics of Go. So let's take all of this that we've learned and create a videos app that deals with video data. The app will have a function to get a list of videos, as well as a function to update the videos. And this will demonstrate the fundamentals of dealing with data such as JSON. Now I like to keep my code modular, so what I'm going to do is create a Go file that deals specifically with videos. So to do that, all I'm going to do is in the videos folder, right click, say new file, and I'm going to create a videos.go file. And then we're going to add the fundamentals. So I'm going to say what package this Go file is part of, which is package main. And then I'm going to import any other packages that we might need. So for now, I'm just going to leave that empty, and I'm going to define the struct of what a video should look like. Now in part 1 we covered the fundamentals of Go, which includes structs. So this is basically a definition of what we want our video object to look like. So a video has an ID of type string, it has a title, a description, an image URL, which is the thumbnail, as well as a URL to the actual YouTube video. And then I'm going to create a very simple function. In part 1 we also learned about functions, so we say func, the name of the function, which is get videos, and we're going to pass no input. You can see that's empty, and the output is going to be our struct, and it's going to be a slice of videos. So basically a collection that we're going to get and we're going to return. Now in part 1 we learned how to populate a struct, which is very simple. So to do that, all we're going to do is remove these comments, and we define a struct like so. So I give the name of the struct, which is just video1. I then put the instantiation character to tell Go that this is a new variable, and I say equals, and I pass in the format of the struct. So this is the struct type, which is type video, and then I just populate all the variables, and this looks very similar to JSON. So I have ID, colon, and the name. Basically key value pairs. And also notice that after every value there is a comma, and even at the end. So there's a comma at the end as well. So what I'm going to do is add 2 videos. I have video 1 and video 2 with different data, and then I can define a slice by saying return a slice of videos, and I can open close curly brackets, and I can pass in video 1 comma video 2. This will create a new slice of videos and return them. So now we have a very basic function called get videos that defines video 1, video 2, and returns them as a slice of videos. Now to use this function, what I'm going to do is head over to main.go. I'm going to remove this line of printing hello world, and I'm going to define a new variable called videos. I'm going to instantiate it with the instantiation character, and I'm going to assign it to the result of this function. So I'm going to call the get videos function, and that will return a slice of video structs into our videos variable over here. And then to see what that looks like, we're just going to say fmt println videos. So to test that code, all I'm going to say is go build. That produces the videos binary, and I'm going to run the videos binary saying /videos, and that will go ahead and print our videos data to the screen. So far in this video, we've been hard coding our video data in our code base, which is great for learning about the fundamentals of Go, such as variables, structs, slices, and functions. But it's not so good when dealing with data, because data can change. If we want to add or remove videos, we don't want to have to go to our code and recompile it. Usually data lives in a database or a data store, a cache, or in the cloud. Data usually takes form of a file, such as a JSON file, XML file, or a CSV. So let's go ahead and make our application more useful by removing the data from the code and storing it in a file. Now, an important part of learning Go is to learn how to navigate the Go documentation by yourself. So we're going to be doing that as we go along. Now, when dealing with reading and writing files, there's a Go package called IOUtil, which is a standard package part of the Go programming language. And we can import this package by saying import IOUtil util. I'm going to copy this and I'm going to go to our import statement and I'm going to add that to our import statement like so. And the next thing we want to do is remove our video data from the code and place it in a JSON file. So what I'm going to do is in our videos folder, I'm going to right click and I'm going to create a new file called videos.json. And then I'm going to paste the video data into the videos JSON file. And you can see this is an array in JSON with two objects representing a video each. Now, if we take a closer look at our variable where we defined our video struct and we take a look at the JSON file, notice that the fields are the same. The only difference is that the struct field starts with an uppercase where the JSON fields are all lowercase. So the Go programming language is able to figure out how to map these fields to the struct directly. We'll take a look at mapping fields a little bit later. So the next thing we're going to have to do is learn how to read that file. So firstly, let's clean up this function by removing those variables. And let's take another look at the IOUtil package. And if we scroll down, we can look at the index and it shows all the functions that are part of this package. And in our fundamentals video, we learned about how to read functions. And we can see there's a read file function. Its name is read file and it takes in one input, which is a file name or path as type string. And it returns a slice of bytes and any error that may occur from reading that file. So now we know that this read file function returns a slice of bytes and an error. Let's go ahead and define that. So we go to our get videos function and we define a new slice of bytes called file bytes and an error. And because these are new variables, we have to put the instantiation character. Then we call ioutil.readFile and we pass in the path of the JSON file. That is the same as the file name inputs of the function over here. So now we have the bytes of the file that we've read, as well as any error that might have occurred as a result of reading that file. As we're building more advanced applications, it's important to notice that we should always handle errors. For now, we'll make sure that the application crashes if it encounters any errors when reading that file, because we don't want the application to continue running if there's a problem reading the file. We'll learn about more in-depth error handling in a future video. So to handle that error, what I'm going to do is I'm going to put an if statement to say if that error is not null, meaning that there is a problem and there is an error inside of this variable, call the panic function. The panic function in Go typically means something went unexpectedly wrong. And these are usually errors that we are not expected to handle gracefully. And then what I'm going to do is I'm going to create a new variable called file content. I'm going to instantiate that variable and I'm going to convert the bytes to a string that we can read. So I'm going to say string, open close brackets, and I'm going to pass in the file byte slice into this function. This is a standard Go function for converting bytes to a string. And I'm simply converting this to a string so that we can read it. So I'm going to say fmt.println file content, and I'm just going to print that content to the screen. So because we don't have any videos just yet, what I'm going to do is just return nil, because we have to return something as part of this function. And because I'm using this fmt package to print out the contents as a test, I'm just going to go up to our import statement and I'm going to add fmt to there as well, telling Go that we want to use that package. I'm then going to say go build, and I'm going to run the application by saying /videos, and we can see that it's print out our JSON content over here. So now we know it's reading the file and printing it to the screen. So now we've learned how to read a file in Go. Now when we read files, you can see it returns a slice of bytes. And to make it readable by humans, what I've done is convert the slice of bytes to a string. That might be useful for us, but it's not really useful for the application. The application expects a struct of videos. So what we need to do is convert the JSON file to a struct of videos. And we want to populate a video collection as a slice of videos. Now for that, Go has a very useful package for dealing with JSON that introduces us to two new concepts, Marshall and Unmarshall. Now working with JSON in Go is pretty straightforward. We have a standard package called JSON, and the package JSON implements encoding and decoding of JSON. The mapping between JSON and Go values is described in the documentation for the Marshall and Unmarshall functions. So two functions that are very important. One for converting JSON to a Go type and one for converting a Go type back to to a JSON structure. So this is very useful for converting a slice of bytes containing JSON to a slice of videos and vice versa. So let's go ahead and import this package by copying this part here and pasting it in our import section. So I'm going to go over to our import block and paste it over there. And if we go back to the documentation, we can see that there are two important functions, one called Marshall and one called Unmarshall. Unmarshall is the function of converting a slice of bytes to a Go type. So we can convert a slice of bytes to a videos type. Marshall is the opposite, taking a Go type, which is our video, and converting it back to a slice of bytes. Now, since we're reading a file, we have a slice of bytes already. So let's go ahead and convert the slice of bytes to a slice of videos. Now we do this using the Unmarshall function, which takes in a slice of bytes as well as an interface, which is going to be our empty slice of videos. Now you can see at the top of the function, we already have a definition for an empty slice of videos, and that slice is called videos. So what I'm going to do is remove this code over here, and I'm going to call the json.unmarshall function, and I'm going to pass in our file bytes as well as a pointer to our video slice. In our introduction to Go, we spoke about pointers. So this basically will tell Go to update the same variable in memory without creating a copy of it. And if we take a look at the documentation of the Unmarshall, we can see it also returns an error. So we have to handle it. So what I'm going to do is I'm going to say err equals, and notice I don't have the instantiation character here because the error is already defined up here. So I'm just going to say equals, which will override any error that occurred previously, and I'll go ahead and handle that error in case another error occurs. So now we're converting our slice of bytes into a video slice. So instead of returning null, I'm going to go ahead and return our slice of videos. And to test that, I'm going to say go build, and to run it, I'm going to say /videos, and we can see we're now printing out the same thing, but this time we're reading it from a file. So now that we have data in the real world, we'll want to do something with that data. So let's go ahead and loop through the data that we've returned and update some terms and conditions in our video description. Now in our Go introduction video, we've learned how to write loops. So instead of printing out the videos to the screen like this, let's go ahead and write a loop which says for every video in the range of videos. And what we want to do is update every video's description box and append some terms and conditions to each video. So what I'm going to do here is I'm just going to say video.description equals the video.description, and I'm just going to append some text to that video description. I'm going to add a new line character, and I'm going to add my terms and conditions for every video. And then once I've updated all the descriptions, I'm just going to say fmt.println, and I'm going to print all my videos to the screen to see the updated content. Now when I say go build and run that application, you can see that my description did not update. Now this is an important thing to understand with loops. When looping objects in a slice, Go will return a copy of that object. So what we've done here is we've updated the description of the copy, not the original object inside of our slice. So to update each video inside of our slice, we have to use the index number. So what I'm going to do is enable the index number. So I'm going to call it I, and I'm going to replace this line with something a little bit different, where I say videos and I pass in the index of the video item I want to update. And then I say dot description, and then I equal that to the same thing, and I append my terms and conditions to that video object. So this will go ahead and update every video object inside of the slice and not a copy of it. And since we're not using the video object at the top here, I'm going to go ahead and silence it with the underscore character, and I'm going to say go build. And when I run it this time, we can see now we have our terms and conditions added to the description box. So now we've learned how to read a file, and we've read that JSON file into a slice of bytes, converted that slice of bytes into a slice of videos, iterated it with a loop, made some updates, and now we want to write it back to a file. So for this, let's create a save function that takes a slice of videos and performs the Marshall function to turn it back into a slice of bytes and write it to a file. So for that, let's go back to our videos.go, and we can see we have our get function. So let's create another function called save videos. So I'm going to create create this function, and this function needs to accept an input of videos. So what we need to do is define an input here. We can define a variable called inputs, and it's a slice of videos. And note that this function here does not return any output. So now what we need to do is we need to take this video slice that we have, and we need to convert it into a slice of bytes using the Json Unmarshall function. If we go back to the documentation, we can see there's a function called Marshall that takes in an interface, which is a Go type. In our case, a slice of videos, and it'll return a slice of bytes and an error. So we can call that function like so. We can define our video bytes, which is our slice of bytes returned by the Marshall function, and we also define an error which may be returned by the Marshall function as well. And then we say Json.Marshall, and we pass in our video slice. And then as we do in Go, we make sure that we handle that error coming back. So we make sure we check whether the error is not null, and if there's any problem, we hit a panic and prevent any further execution. So now we've taken our slice of videos, converted it into a slice of bytes, and now we can write it to a file. And to write it to a file, we can take a look at the IOUtil package again, and there is a write file function which takes in a file name or a path and a slice of bytes, as well as permission for that file, and returns a potential error. So what I'm going to do is call that function. Now we can get an error. Notice that I did not pass the instantiation character here because the error is already instantiated at the top. So I say error equals IOUtil.write file. I pass in the path, and in this demo I'm just going to pass a different path. So I'm going to write a new file in this case and not update the existing file. I pass in the video bytes, and I pass in the permission for that file. And then as always, I also have to handle that error that comes back. So if the error is not null, we hit a panic. And that is our save function ready to go. So now what I can do is head over to my main.go, where we retrieve the videos, we do the update, we print out to the terminal, and now what I can do is finally, after we've done our update here, I can go ahead and save the videos by calling our save function. So to test that out, I'm going to say go build, and I'm going to run my new code by saying /videos, and we can see it's printed out to the terminal. And if we take a look at the left here, we can see our videos updated.json file, which is what our save function has saved. If I click that, we can just format the document, and we can see we have our updated videos JSON file in here. Now we've learned how to read and write files and how to convert JSON data into structures that we can use inside of Go. Now in the real world, we might not be writing files, but we can use the same fundamentals to write these data structures to things like S3, Elasticsearch, and other types of data storage. The key thing here is using the IOUtil and the JSON package and knowing how to read and write data using slice of bytes and converting them with the Marshall and Unmarshall functions is key to working with data structures such as JSON in Go. But sometimes there is a case when the fields in JSON data does not match the fields in our Go type or in our Go struct. For this, we might need to use mappings. Mappings are important in the case where the fields in the JSON, as you can see on the left here, does not match the fields in our video struct that you can see on the right here. In our case, they match, but sometimes they may not match because the JSON might be coming from another system. So to do this, the Go programming language struct type allows us to do mappings for each field. So if I go to my videos.go and I go to the struct, I can add mappings to each field. And I do this using the backtick and then specifying the field in JSON I want to map to. As an example, I can replace all of these fields with this. So you can see here I pass in the backtick JSON, and then I refer to the field that is matched in the JSON file. So this tells the Go programming language what field to pick up in the JSON file and what to map it to in our field in the struct. And it's always recommended to explicitly tell Go which fields to map to. So now we've learned about the fundamentals of Go and how to work with data structures. These are essential building blocks of learning how to work with data structures in memory as well as with data stores, and learning how to store data in various systems. This can involve connecting to databases. We can write our own web service and serve this data up via HTTP. We can write applications that connect to other APIs or microservices and send data across the wire. Now stay tuned as we'll take a further deep dive to learn more about these concepts in Go, and we'll push our learning to the next level. If you liked the video, be sure to like and subscribe and hit the bell. And if you'd like to join the community, be sure to check the join link in the description box below. And if you want to support the channel even further, be sure to click the join button below and become a member. And as always, thanks for watching, and until next time, Peace.